Okay, hi students, welcome back. Today we are going to talk about momentum and conservation of momentum. So this was the topic I told you that we'll discuss later, okay? So under the chapter of force and laws of motion, today we'll talk about these topics which were left, okay? So inertia also we'll discuss a little bit. So we'll cover inertia. We have already talked about inertia, so you know pretty much about it. Then momentum, that is the quantity of motion of an object possesses. Okay, so if object is in motion, how much quantity of motion, that how much motion it is in. Okay, that we are going to talk in momentum. And conservation of momentum. So motion is never lost, only transferred between objects. So suppose if something is in motion and it crashes with something, so this also will move, right, to a certain extent or certain amount. This vehicle will. So that is why the momentum is always conserved and it is not, being lost. Okay. So inertia. Inertia is resistant to change. Again, we have discussed this, and inertia depends on mass. Okay, heavier objects have more inertia. So the tendency of a body to resist any change in its state will be more in the body, which is okay. For example, there is something very heavy. Okay, a very heavy box is there. So moving that would be more difficult than moving a very small, teeny, tiny Rubik's cube. So this is a big box and this is just a small Rubik's cube which you play with. Okay, have different colors to it, right? Okay, 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 right? So moving this would be easy because this has less mass. The mass is less here, okay? Less, let's write less. And here more mass is there. So moving this would be, difficult because it will resist more. This has more inertia and this has less inertia. Okay, now common examples. Passengers jerk forward when, again, I have told you this in last session. You can just go back and check. Again, I'll tell you. So passengers are moving, right, in motion, and suddenly the bus stops or the car stops. So you will tend to get a jerk because you were still in motion and you are resisting the change. Okay, your body is resisting the change and you have inertia. Okay, dust comes off a carpet when shaken. Again, dusts are lying there just like that. And when you are shaking it, you are changing its state of motion. Okay, and ball continues to roll until friction slows us down. So friction is there on the surface, every surface, right? If not, then everybody will be slipping here and there. Okay, so ball is moving. After a certain point, it stops due to friction. Okay, now types of inertia. So inertia of rest. Body resists motion from rest. Okay, and for example, would be a book which stays on the table until it is being pushed by us. Then inertia of motion. Body resists stopping while moving. So it resists stop unless you're providing a brake. So once you brake, the passengers will feel the jerk. Okay, forward direction. And inertia of direction. Body resists changing direction. Water spills sideways in a turning car, maybe. Okay. Okay. Now, quantity of motion, momentum. This topic I haven't touched. This comes under the second law of motion. Okay. So here we'll discuss it. Momentum actually is the quantity of motion possessed by a moving body. What do we mean by that? That momentum is denoted by P, first of all. This. Okay. The body has certain mass and it is moving with a certain velocity. Okay. Now once this momentum is there and it has certain mass and moves with a certain velocity, what happens here is that it has a quantity of motion. Its motion has certain quantity. Okay, certain amount in which it is moving, right? So that is known as momentum, and it tends to have momentum unless you're again providing some external force or brake, or unless you're resisting the momentum in a very greater force. Then only the momentum will be broken and it will stop. Otherwise, it will keep moving. Okay, so a truck has more momentum than a bicycle at the same speed due to greater mass. Because its mass is more, so more momentum here and less momentum in a bicycle. If something more small is here, okay, So it will have more or less momentum because mass, it is directly proportional. The momentum is directly proportional to the mass. Okay. Now, how to calculate momentum? Again, I have told you, momentum depends on two things. First is mass, second is velocity. So suppose if you're given with a problem that a cricket ball with a mass of, let's say what we know, mass, that is 0.2 kgs. Okay. Thrown at a speed of 20 meter per second. So speed is 20 meter per second. Okay, just ignore this. Okay. Now, what happens is, what is its momentum? So momentum would be this, okay, 0.2 into 20. Okay. Now, this will be, if you will calculate, it will come out as 4 kgs. Okay, per meter, meter per second. So that means that it will be having a momentum of 4.0 or 4 kg meter per second. Okay, so this calculation shows that even a small object like a cricket ball can possess very significant amount of momentum when it is moving with a very, very high speed. Okay, because here the mass was less, but the speed is high. If the mass was more, then also momentum will be more. Now, they talk about the conservation of momentum. Okay, so when two or more bodies interact with each other, what happens? Their total momentum before and after interaction remains constant if no external force acts. So what happens is basically when two bodies are interacting. Okay, so body 1 and body 2. Now they are interacting, they're colliding. Now their total momentum before and after remains constant in total, in sum total. So if no external force is being applied to these, it will remain like m1, q1, that is mass 1, and velocity 1, mass 2, velocity, sorry. Here, let me just reduce this. 2, okay, and m1, v1 for the second object, and m2, v2, right? Now what happens is, after the momentum before collision equals to the total momentum after a collision. Okay, so once the collision or the crash has been occurred, what happens is, yet after the collision the momentum is same, it's not changing unless you are providing a unbalanced force to it. So applies to the collision, explosion, for example, collision, explosion, and rocket launches. It's seen there in those, the momentum is seen, and works in isolated system with no external forces. So if no external forces is being provided or given to two objects, it will have the same momentum. The momentum will remain, again I'm telling you, it will be constant, it won't change easily. Okay, so application would be again the rocket propulsion, which we were discussing, the jumping from a boat, which we were talking about, and the sports collision. Okay, so when you are playing a billiard maybe, so in that when you are hitting the ball, so it stays in a motion or momentum unless it resists something. Okay, now the questions would be, which of these have or has maximum inertia? Bicycle, scooter, truck? Okay, so just answer this. Now, you can remember, the velocity and the mass concept related to momentum. A body of mass 5 kg moves at 10 meter per second. Its momentum is 50 kg meter per second, 5 kg meter per second, or 10 kg meter per second. You have to answer this. So what you can do is, they're asking you momentum, so you have mass given, right? And you have velocity given. You can just multiply it and come up with an answer. Okay, which principle explains the rocket launches? Is it inertia? Is it conservation of mass? Or is it Newton's first law that is related to inertia, right? Okay, so thank you so much for joining the session today. I hope you enjoyed. And just let me know if you have any doubts or any queries. Okay, and you can reach out to me on my Urban Pro profile. Thank you so much. Take care. Bye-bye.